Hello and welcome to online multiplayer experiences on the PlayStation 5. My name is Bendik Neunfeld. I'm a game experience staff solution architect with Sony Interactive Entertainment. I've been with Sony for about 8 years, and the better half of that I've spent as a solution architect working on game services and focusing on the experiences we deliver to our partners and to our players. In this presentation, I want to take you through three main topics that we kind of went through as we were building the online multiplayer experiences. The first one, re-envisioning the online multiplayer experience, will kind of cover the ideas and what we delivered for the PlayStation 5 to make new experiences. After that, I want to share a little bit of the philosophy and the strategies that we had in mind when we were designing the systems. And finally, we'll cover some building and scaling. So let's get started with the online multiplayer experiences and how we re-envisioned them for the PlayStation 5.
PlayStation.
Alright, so let's take a look at some of the new features we introduced for online multiplayer on PlayStation 5. Already on PlayStation 4 we had the concept of sessions and invitations to allow players to invite their friends and play together. On the PlayStation 5 we wanted to expand on that concept and take it a step further. So we introduced dedicated sessions for system UI usage that the game and the player can control in order to interact with each other.
Further, we wanted to give users the ability to have more information about what's going on in the game. As such, we developed a system to allow the game to post information about the ongoing matches and what's going on in the game and the progress the user is making, and then resurface it on the system UI so that the user can make an intelligent decision about whether to join or not. Further, we started supporting voice chat on the system UI, but also surfacing in-game voice chat directly on the system UI and allowing users to switch easily between the channels that we have. So this brings me to the SDK features that we introduced for the new online multiplayer experiences. The first one being voice chat, which is directly tied to game sessions, which use game system resources. What that means is any game can use the voice chat that we've implemented on the PS5 system layer within the game easily from the sessions. It also allows users to switch between the voice chat channels. For example, a game might have a channel for the team chat or a channel for the match chat. But the player might also be playing with their friends, so they can switch between the channels in the system UI. Further, one of the feedbacks that we got from our game partners was the support for global session search and matchmaking. On the PS4, we had multiple systems to support that. But going back, we wanted to make sure that we have one system that introduces a cleaner flow for the developer and for the players. Finally, one of my favorite features is probably the spectator slots that we also introduced as part of the feedback we got from game partners. Oftentimes you find when you want to join your friend in an online match that the session is full and you might not be able to join, or maybe you just want to take a sneak peek at it. In this case, we do support system-level spectator slots that allow a user to jump into a session using the system UI as a spectator, and then maybe get queued up for the next match as it's coming up. Next, let's take a look at the design philosophy and the strategies that we kind of set out for ourselves when we decided to work on online multiplayer. First, we started with our vision for online multiplayer, and as it states here, it's relatively straightforward and simple. Build a best-in-class online multiplayer platform that connects games and players. The important part for us was the part that connects the games and the players together. Online multiplayer is really, as a platform, bringing the players into the games and ensuring that they have a good time together. In order to achieve our vision, we set out with our principles. And the first principle was listen to our partners. Our game partners that we work with on a daily basis have a lot of knowledge and experience in online multiplayer. So we wanted to make sure we get their feedback and their input on the systems that we're building as quickly as possible, as soon as possible. With that in mind, we wanted to make sure we build a platform with developers in mind. We didn't want to build a platform just for the sake of building it, but we want to make sure it's a platform that's easy to use by games and by players, and that appeals to both. The second principle is extremely important as well, because it states that the base SDK services stability is paramount. What that means is the services themselves that power these core SDK experiences must be stable and reliable. Our service can under no circumstances get in the way of the gaming experience. We can't be breaking in-game experiences just because the game integrated with our SDK. However, as a different side of SDK stability, the SDK itself must be stable. And what that means is, once we release an SDK, we can't really go in and make breaking changes to the SDK. It would mean breaking the integrations that the games already did themselves, that you and the game partners spent so much effort into implementing, and we would be breaking those. That's a bad experience, not only for the players, but also for the game partners, and in the end also for us. But we also must be able to introduce new features. So the last principle was really about enabling growth. We wanted to make sure that our services and SDK offerings are able to grow even beyond the launch. Introducing new multiplayer services don't normally end with a generational jump in the console. No, we wanted to make sure that we are able to grow the services and continue to respond to the feedback and the feature requests by you and by our game partners and our players, and make sure we can grow the platform with it. Secondly, enable growth is not only for the platform itself, but also for you. So we want to make sure with the platform we're giving game partners the right tools to grow their online multiplayer experiences and rely on some of the features that we offer to enable new experiences in their game. Next, I want to talk about some of the challenges that we faced as we were going through the vision and looking at our principles. The first challenge was PS5 was a massive engineering effort. On top of that, we had to deal with COVID. Working from home meant for us limited access to hardware resources, less PS5 test kits that we could work with, that we could run software on that we wanted to test. But on top of that, even though the online multiplayer core SDK service is only developed by a single team, The overall experience that it's enabling is touched by more than 10 teams, which are located across 3 to 5 different time zones, depending on where the teams are currently moving. So we had to coordinate that massive engineering effort and make sure that we have the right SDK release milestones and the system UI release milestones. The second challenge was that we cannot leave the PS4 systems behind. PS4 is by no means for us a legacy platform. No, it's a platform that still continues to be used a lot. So we needed to make sure the core systems behind the PS4 must continue to be functional and working. But further, we wanted to give game partners the ability to switch from the old system that we had in the PS4 to the new system which supported both PS4 and PS5 at their convenience. So in many cases, those two systems needed to exist gracefully next to each other without interfering. The last challenge, and it comes as we look closer at the UI and everything coming together, is the tight integration between features. A lot of different features need to come together in order to create the experiences. Later, I'll be showing some more zoomed up screenshots of the user experiences. But having all those services come together, providing the information, and then combining their information to create the unique user experience means we have a lot of integration points in the systems. And usually having a lot of integration points means having a lot of failure points. So in order to counteract those challenges and make sure we can still achieve our vision and the principles that we set ourselves, we kind of brought some of them into the architecture design. In this section, I want to quickly go over a few architectural milestones and pillars that we put up in order to make sure we could achieve what we set out to achieve. Let me get started on the first pillar of architecture design, flexibility. At the top right corner of the slides, you can see the AWS services that support us in ensuring our architecture design and enabling us to get to the right milestones. Flexibility means we wanted to make sure that our architecture is flexible and easily expandable. As we were just rolling out new features and introducing new components, we want to make sure we still have the ability and the agility to respond quickly to feedback from partners on our early SDK releases, but also from players. However, having more flexibility also means a higher importance of system availability and stability. Further, we wanted to avoid monoliths, but we didn't want to overcommit to microservices. We're managing services at a level where scaling matters. What that means is services are built in a way that they can scale as much as they're required to. The second and third architecture pillar are separate concerns and using managed services as much as possible. Separating concerns is a relatively standard architecture principle, but I still wanted to call it out because it was so important in how it impacted our architecture. We broke out key logic shared across the service into what we call edge services. Those services are dedicated to handling authentication, authorization, rate limiting, asynchronous updates, and in many cases they have their own cache instances to cache data locally and return it to the clients much quicker. The third principle was using managed services as much as possible. We wanted to allow the teams to focus on what is important to them, the core logic of the services, and enabling the good experiences. The last pillar was decoupling services asynchronously when possible. Because of the complexity and the many dependencies across the systems, we wanted to use events and event sourcing to power downstream dependencies and experiences without impacting the core SDK services. Of course, that is a complexity versus availability trade-off, but allows us to keep the core SDK stable, going back to our original pillars, while also being able to power more advanced features down the road. Let's jump into the architecture. All of the architecture kind of starts with the network and routing layer, the box on the left. What it does is it routes traffic globally, and it has some security measures in it. But basically, game servers, games running on our consoles, the consoles themselves, and our non-console apps are all talking to the network and routing layer to get to where they need to be. Once they arrive in our AWS regions, they go through the session edge services. Those are ALBs with ECS instances and a Redis cache attached to it. What they are doing is they're checking the access token, making sure the access is valid, and they're also making sure the rate limits are being respected. Once everything is validated, the traffic goes to the session core service, and this is really the core SDK logic that we have. Again, it's grouped into an ALB and ECS, AKS instances, talking to its own Redis cluster to make sure that all the sessions are locked and that we have the right amount of people in them. But you also have, at the end, an SNS that the session core is asynchronously publishing messages to after writing it to its own Redis cluster. The way we used this asynchronous updating is we connected the simple queue service to the SNS, which then is consumed by the session search service. What that allows us is to keep the session core itself stable and making sure it can focus only on its core component, which is session and invites. However, we wanted to add more functionality on top of that. Using SQS, we can update the indices that are created by session search in Elasticsearch and DynamoDB, and then access them asynchronously through a session edge. Session edge can then, if necessary, check with session core if the sessions are still alive, or get the latest information from the sessions. But the search itself, returning the session IDs, is done asynchronously in session search through asynchronous updates and decoupled through SNS and SQS. Another big important part about online multiplayer is making sure that the clients and the games know what's going on in the cloud. We can't just be accepting updates and then not telling anybody about it. So whenever a user joins, whenever a session is created that's relevant for you, we will use what we call the push services. Those are services of certain magnitude that allow us to push information directly and proactively to the console and tell games, hey, user B just joined the session. Or call other hooks on the console to make sure that the system UI stays updated. So in this image, you can see the system UI on the PS5. It not only shows sessions that are joinable to you, but it also shows match information or other cards for recommended activities. The way this is powered on the PS5 is again using the SNS SQS established pattern, where updates and session creates are forwarded to dedicated UX services. Those UX services then create indices on their own, bound to the user experiences, to make sure that we can proactively and really quickly provide users with the latest updated information. UX services, once they've identified a certain update is important to you, they will also use the push services to proactively push the data to the console and tell the console to refetch the data from the core services. Let's get started on the last section, building and scaling. In online multiplayer, scalability is key. Unless you're able to scale, users will most likely have a really bad experience playing online, especially if your game is selling really well and you have a lot of users. And as such, traffic patterns can be really unpredictable in online multiplayer. On the left, you have a graph that I want to talk you through. It's part of an experiment that we did before the PS5 launched in order to make sure that our services can stand up to whatever you and our players can throw at it. Let's take a closer look at the graph. In pink, you can see the baseline traffic in the bottom fifth of the image. But then we started a simulated outage, and we did that by certain configuration flags that we have. But you can see the moment the simulated outage started, the traffic is slowly trickling off. That is because access tokens and other information is expiring, and clients will no longer be able to access the network. And then we ended the simulated outage and allowed all of the clients, all of the console that we had targeted for this, to come back to our platform. And we saw a traffic increase by more than 5 times over a few minutes. Those kind of spikes are representative of the core of the scalability that we need to deal with. We need to make sure that if an in-game promotion is causing people to flock to your game and play more online, that we can handle that. And it's those kind of traffic patterns that we need to be prepared for. The key takeaway from this presentation that I want you to take home with you is we are super passionate about creating awesome experiences. And using cloud services allows us to focus on that. It allows us to make sure we can do our best to make awesome experiences for you and for the players. Thank you very much.